Welcome back, students, to Lab 2. So in Lab 2, I will actually introduce the third-party package quantmod. And quantmod is the third-party package that allows us to download stock data straight from Yahoo Finance. It's a very nice, nifty piece of software that we'll use throughout the semester when we're dealing with daily prices. Now, quantmod does not give us intra-day prices, tick-by-tick prices. It gives us end-of-day prices for each stock, right? For each stock. So let us begin, right? I say the code is on Blackboard. I'll post the code under cr_benchmark.r. All right, that's fine. I'll just rewrite it again in my R Studio. I'll name it cr_benchmark.r so you guys have it. All right, so let's go ahead and jump into it. First things first, I open up my R Studio, right? Notice again, just as a refresher for you guys, if I want to open up a new R script file, which I do, I click on the green button over there. You see all the files at your disposal. I'm going to go ahead and click the R script. That's the one I want, and I'm good to go. Let's make it slightly bigger so you guys can see what's going on. All right, so I'm going to save this, and this time I'll save this as, only because of my slides, I have it as cr_benchmark. So I'll save it as that under summer, so I can post it for you guys on Blackboard. So you have it, in case you need it. And I'll save this one as cr_benchmark.r. I don't even need to put the .r, it'll do it for me. See, boom, done. All right, excellent. From here, guys, right, like I said before, there's a free package that allows us to download those stock prices, right? Download those end-of-day stock prices. And it gets it from Yahoo Finance. If I can show you. All right. If you were to go to finance.yahoo, not Google, I'm in Google. Just do finance.yahoo.com, right? Finance.yahoo.com. I'll zoom in a little bit. You stick a symbol in here. Let's do Apple. And boom, you have all these prices at your fingertips. All this information, all this information at your fingertips. And more importantly, what you also have is the historical prices, right? Where all these charts come from. Where's historical prices? Right. First off, if we go right here, where there's summary, scroll over, chart, conversation, stats, historical data. Ooh, conversation. So people can talk about, here people talk about what they expect to happen with Apple. Again, this is being Yahoo. I wouldn't really trust the people discussing it. You have statistics, right? The stats behind it. All right, look, these are very cool financial ratios. Give you little stats, very cool. You have something else. If you click here, financials, like this is really cool. This pretty much gives you the financials that we are actually going to use to make our ratios, right? And as you can see, they have 3 years. We used to be able to download this using quantmod, but Yahoo Finance stopped sharing this with us. That's okay, because now I actually have a stack of data that I give you guys to use it, to get the data, and to use the data anyway, the historical data. So you guys will see that. I have to have the data set. I have it up to, the cool thing about it, that data set, is I have from 1988 to 2017. So I'm missing the last 3 years. I don't have 18, 19, 20. But I can get that data as well. But I mean, what we have is fine, what we're doing. And then you have analysis, and then you have options. These are option contracts, right? You guys aren't ready for that. We used to be able to download this too, but we can't download that anymore. But what we can download, and what we really care about, is if you go to historical data, right? What you see here is the historical prices, right? The historical prices, along with some additional information, and I'll talk about that. All right? So that's basically what's happening. That's what we're basically downloading in quantmod. Now, to use quantmod is not a native R function. QuantMod is a third-party package, right? A third-party function or software. I'm sorry, it's a third-party software written by somebody else, some really bright individual that created it for our use, right? A lot of people, because of the fact that R is open source, many individuals, institutions, universities, they write these different R packages around the world, and they release them into the environment, the ecosystem of R. Think the same way how apps work, how the app market works for Apple, right? Same concept. So we can download any one of these software packages via RStudio and use it. How do we download it? Now we're going to go to the bottom right window. Under the bottom right window, you will see that there are 5 tabs. 5 tabs. Files, plots, packages, help, and viewer. The middle tab, packages, that's the one, that's one that basically manages or helps us install our software. And it's real easy. You go over here, you click install, and this window pops up. From here, you're going to type in quantmod, right? There it is. You want to keep that checked, install dependencies. It's going to install not just quantmod, but all the other packages we need. Click on install. And by the way, you obviously have to be online. And it's going to go to the internet, and it's going to start grabbing all the quantmod stuff. Now, for some of you guys, the PCs, see, I'm on a Mac, so it was pretty easy. No problem. For some of you guys on the PCs, it might ask you, hey, do you want to do an easy install or hard install or something along those lines? Pick the easy one. Always pick the easy one. All right? So I have quantmod installed. And how do I know it worked? Well, first thing I need to do is, let's see, do I show you how to test it? Okay, cool. We jump right into it. So the first thing I need to do is I have quantmod installed, done. Now, we downloaded quantmod, you have it. You never have to download it again unless you're getting the latest version, right? Outside of that, you don't have to run the install packages anymore when you want to use it. When you want to use it, you have to now import that software into your memory so R can use it. Now, why is there a difference between installing the software in R and using the software in R? The reason is very simple. Forget the third-party software packages for R, the native packages in R that come pre-built, right? There's tons of them. If you were to load up all those libraries and packages, then if you were to load up all those libraries and packages that are by default come with you in R, then what would happen is your memory would come to a standstill. You wouldn't be able to use your computer. There'd be too many libraries loaded up into your memory. This is why we only load up the libraries we need, so that our memory is free to do other kind of processes. So that's the logic behind it. So any of you that have done Python foundations, you guys know what I'm talking about. The import command in Python, that's what's happening. The import command, you're calling in a library, be it a third-party library or a native one, that you're going to use, that's going to be installed in your memory, and it's good to go. The functionality is there for you to use. That's what we're going to do with quantmod here. Now, how do we do it in R? Very simple. The function name is library. Right there, library. That command library loads up any, be it a native package or a third-party package that isn't loaded up in R by default. The one we want to load up, obviously, is quantmod. Process the line. You'll see some other things like this loaded up. That's fine. Some of you will, again, when you load up quantmod, it's going to ask you to maybe install another package. That's fine. Go ahead and do it. Again, this is the PCs. You guys have different packages in PC. It's not really uniform like it is with Mac. So you might have a certain package that has been loaded or hasn't been loaded, and it's going to ask you to load up an additional package. That's fine. All right. So now we have quantmod loaded up. Let's go ahead and run it. Okay, let's go ahead and run it and see that. Now, if you didn't get any error, then you're good to go. But either way, when we run it now you're definitely going to know whether you're good to go or not. So the first thing I want to do is I want to use the get symbols command to download prices. The command I use to download prices is called get symbols. There it is in the dropdown, and it works very simple, right? It has a lot of parameters. It has a lot of parameters. There's a lot of customization you can do with it. But right out of the box, it's real easy to use, and all we have to give it is the ticker that we want the price data for. All right, so I'm going to type in quotes, Tesla, right? Now the way get symbols works is you have to put it in quotes because we're giving it a name. We're giving it a ticker name. That's why it has to be within quotes. Now, when you're giving the ticker name for get symbols, the way get symbols works, it does not have to be all lowercase. It can be all caps, a combination of lowercase, uppercase. It does not matter. Get symbols deciphers it based on the letters, not the case, whether it's uppercase or lowercase. So this is fine. I go ahead and run this line of code, and all of a sudden, what do you guys see? Down here, Tesla pops up, the word Tesla. Up here now, something happens. Up here, under data, it's saying Tesla in all caps pops up, some sort of data container in all caps, and it's called an XTS object, and it gives you certain dates right here. Okay, what we did was we just downloaded a table of prices. That particular table of prices is a special kind of table. It's a special type of data container. There's many. The default table in R is what we call data frames, and I'll briefly talk about that. Briefly, because we really don't use it that much. We use data tables, which is a third-party package, and it's a lot more faster and powerful. But this is what we call an XTS object, right? An XTS object, Tesla. If you want to, right next to here, you see this little box here, guys? This little box right here all the way to your right? Click on it. When you click on it, look what pops open. The table. The table. The XTS object is a fancier version of the data frame. It's an object, it's a data frame, it's a data container that's basically a table where each row is assigned to a certain date. And that's what you see here. See these dates right here? Each one of these dates is basically identifying each unique row. Now, what type of data is this? What kind of table is this? It's a time series. It's a time series. This is exactly what you're looking at. It's a time series. And the XTS type of table is perfect for time series because it allows you to index each row. I'm using a MIS term here. Index each row with a particular date. In this case, a single end of date, right? So there's not 7 columns here. Oh, no. There are 6 columns. There's 6 columns in this table. This right here is not a column. This right here would be the index of each row. Okay, would be the index of each row. And it's pretty cool. Right here, what do I see? I see the Tesla prices. Guys, by the way, check this out. 2010, approximately about 10 years ago, Tesla was like 25, 19 bucks, huh? Hindsight. All right, so if you scroll all the way down, you can see that this is actually the data is ascending. It's ascending, right? It's getting a bit lower. It's going from the past to the present, the past to the present. Let me close that up. So that is basically the Tesla data, right? Here I'm grabbing SPY data, and I should have grabbed SPY, but whatever, it doesn't matter, right? So SPY over here, by the way, we'll talk about this a little bit later. This is actually what we call a ETF, and I'll talk about a little later in the lab. We actually tackle the lab, what the ETF is. So let me show you some more of the parameters that you can use to get a little more control of over the data you're getting. By the way, those stock prices, they're coming straight from Yahoo Finance. They're coming straight from Yahoo Finance. All right, so I can also do Tesla, and I can add another parameter keyword called from, right? And from right here, what I can do is I can specify, oh, you know what? I don't really need it from 2010. What was it, 2010 I had it from? Right, we can, if I click on this, yeah, I had it from 2010. I'll say, you know what? I don't need it all the way from 2010. You know what? Why don't you give it to me from 2018? And so now I will type in the date from 2018. And watch how I do this. First of all, the date I give, I have to put in quotes. That's number one. The date must be put into quotes. Number two, the date must be specified in a certain format, the way R understands it. It just so happens R understands it the way same way, in the same format Python understands it, which is to say a 4-digit year. That's why I'll put 2018 dash 2-digit month, January, dash 2-digit day, the first. All right. So basically what it's going to do is now Get Symbols is going to look for Tesla, all the prices, starting from, instead of 2010, this time January 1st, 2018. Now, if there isn't a stock price or a transaction as of January 1st, 2018, that's okay. It'll simply start off from the first transaction in 2018 after the first. It'll just keep going down, looking for when the first transaction is and start from there. So when I go ahead and execute this, notice what happens again. Down here, I got Tesla, and this object changed. Again, it doesn't look like it, but it changed. If you click on this right here, the box all the way to the right, where my little hand is, now you will see that when it opens up, it doesn't start with 2010 anymore. It starts with 2018 01-02. Why -02? Because there was no transaction date on the first. And we all know this. It's New Year's Day, guys. The market's closed. So it looks for when the next transaction happens, which is January 2nd. All right? Let's add, let me show you another parameter. We can also add the to date. Let's say I don't want it all the way to the end. Let me show you a nifty little function here, guys. I'm going to show you guys a nifty little function here. This function is called tail. Right? And basically in tail, I can put in, the way tail function works is I can put a table in there and it'll show me the last rows that I specify. So let's say I want to show Tesla. Now notice I'm putting the table name in there. Not the ticker. No, not the ticker. I'm putting the actual table in there, which is named Tesla. And I'm saying, give me the last 6 rows. I run this, and down here in your console, you will see, let me scroll over a little bit, so it's all in one row. It carried it down because I didn't have enough space. So let me do this again. And now I have it all excellent on one row. And you can see this is, for that table, the last 6 rows. That's the tail function. And obviously, with the tail function, there's also something called the head function. And this will give me the first 6 rows of the table. All right, nifty little function. So if we go back to the tail, you'll see that the last date I have is for May 29th. Why do I have it for the last? Why is my last day May 29th? Right? As of the video I'm doing it right now, I'm doing it June 1st, Monday. There should be trading information for today. No. It is because these prices are historical. They only give you to the last closing day. So because the last closing day was the 29th, it gives you the price as of the last closing day. Okay? So from here, let's say I want to get it from the beginning of 2018 to not the 20th, not to the May of 20th, but to the end of the 19th. All right, to the end of 19th. So December 31st, 2019. So now I'm going to add another parameter, comma, called 2. And 2 is basically up to the date I want it. Typically we don't use this. Typically we always we want the most recent date, but there could be situations where we might not. So now I will type in 2019 in the same format, dash 12 for December, dash 31st for the 31st. Now what will happen here is, for the 2, it will look for transactions up to this date. If it doesn't have a transaction for that date, then it'll go backwards. It'll look at December 30th, December 29th, December 18th. Whereas the from went into the future, the 1st, the 2nd, the 3rd. The 2 will go into the past until it finds a transaction. And that's how you can find these transactions within these dates, even if you don't know the exact date. So if I run this again, Tesla popped up in the profile. On the top right, you see Tesla there again. If I click on this, you see we start with this 2nd again, and let me scroll all the way down. And when I scroll all the way down, you see the last row is 2019, 12/30, not 31st. That's okay. So it didn't have the 31st, so it just got the next. It went to the next second to last day or third to last day, whatever, and they had transactions. And now I have prices from that point to this point. By the way, look at this. December of last year, 5 months ago, Tesla was around 428. Right now, Tesla is 800 something, reaching close to 1,000. All right, reaching. Not. I mean, it's going to reaching close to a 900, on its way to 1,000. All right, insane stock, people, insane. Let me say that. So those are the first two initial parameters. Those are the first two initial parameters. So these parameters are pretty straightforward. The next parameter I'm going to show you seems to cause, is a little controversial because some people get it, some people don't. The auto-assign parameter. The auto-assign parameter. All right, look, a lot of people get this wrong in the first midterm. Less people get it wrong in the second midterm. By the final, hopefully people get it. So it's a concept for some people that it's kind of difficult to grasp. But let's just jump into it. Get symbols. Will you notice something about it? Get symbols is creating a data container. It's an XTS. The type of data container is an XTS table. That's fine. But it's creating something. All right, it's creating something. Now, remember I talked about this before. When there's a single equals, like for example, when I do x equals 5, and please don't confuse this single equals with the single equals from here or here or here, because these are being done within the parentheses, right? So that's basically you're setting a value to a parameter within a function. That's different. I don't mean that single equals. I mean a single equals like this, outside of a function. We said that when you have that single equals, it's either creating a data container or transforming an existing data container. We talked about this, right? If I run this, you see it up there, right? Done. Okay, in fact, you see it as something different than the actual table up there. Now, how is it that this function now is when I run it, it creates this data container? There is no single equals. There is no single equals, right? What's going on? What's happening is behind the scenes, get symbols is creating the single equals. It's naming the data container and it's executing the code and storing it over here. The data container it creates is basically the name of the ticker in all caps. That's the name of the data container it creates. And that is why Tesla popped up here in all caps. But let's say, hypothetically, we didn't want it to be that name. Let's say we want it to be something completely different when we call get symbols. Enter the auto assign parameter. Let me copy this. I'm going to drop one of the parameters just for the sake of easy to see. Let me drop the 2 one, right? And now I have the auto.assign parameter. See that? The auto.assign parameter. And this I will set to F to represent false. In other words, the default value for this parameter when we're using it here, here, and in line 6 is true. Behind the scenes, auto assign is set to true. Here now, explicitly, we're setting it to false. Why are we doing that? Because we're telling get symbols, hey, get the Tesla data for the dates I want, but don't create a data container, this data container right here. No, 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 no. Create my own data container, and that is when I put in the single equals, and I'll put in a name, for example, Batman. Let me scoot over a little bit. Batman. And now a new table or data container, Batman will be created with Tesla's data. If I run this, in fact, let me change this up just so you guys can know that it's different. So I'll do it from the beginning of 2020. Right? I run this. Bam. Batman's up there as a table. I click on this, and you'll notice it's all Tesla data starting from the 2020 and going all the way down to the most recent data, which is May 29th. All right? Do you see that? Everybody see that? I just closed it, but I mean, if you open it, you'll see. So that only worked. The only reason why we have, and notice this Tesla table was untouched. It's still starting at 2018. You see that? That is because a new data, this like before, this data container wasn't updated. This new data container was created. And the reason that happened is this little parameter right here. Now, if I were to do, let's stick with the DC theme, shall we? Flash. Let's do flash equals get symbols Tesla, right? And this time, let me run this right here. I run this. Notice what happens down here. There is no output for Tesla. In fact, we didn't have that over down or for Batman either. Okay, fine, fair enough. But look what pops up here. A variable called flash pops up with its value Tesla. In fact, if I type flash down here, it's not a table. It's literally the word Tesla. So that didn't work. What happened? What happened here again, if I click on this Tesla, you'll notice now it's 2010. Why is it 2010? Because when I executed line 10, get symbols is like, all right, cool. I'll run get symbols, and auto assign. We auto assign by default is true. Therefore, get symbols went, recreated this data container in all caps, and put the new or the whatever prices for Tesla in it, starting from 2010, going all the way down to May of this year. The equals flash simply got the output of that function, which was the word Tesla. Flash, unlike Batman, did not become an XTS table with those prices. Why did that happen? Because you didn't do auto assign equals F. It is not until we do auto assign, right? And now I run this, and now you'll see flash all of a sudden is not here, it's up here, and it is an XTS object. I click on that, boom. All right? That is what auto assign does. Auto assign lets us explicitly decide the name of the data container, where those stock prices from Yahoo Finance are coming from and going to, and what kind of XTS object, the name of the XTS object that will hold those stock prices. So that's basically what auto assign does. All right? Good luck with that. It's a little controversial in the first midterm, but try it out a little bit. Hopefully you guys will have some questions on in the QA sessions. All right, now let's talk about this data frame. Okay, let's talk about the data frame, and let's talk about what these columns mean, what's going on. All right. So again, there's 6 columns. Each row has a special index, right, which is the dates, and this allows for, again, a time series to be loaded up into R and to be used like a time series. So you have total control of the chronological order of data, and you can sift through the dates and the subsets much easier. And I'll show you guys that a little bit later. How you have it's so much easier to get a subset of data based on certain dates or time. It's very cool. All right. Now to the 6 columns. What do they mean? What's going on here? So for my people that have done a little trading here and there, you guys understand what this stuff is. For my bait students that are new to this, let me break it down for you. All right. The first 5 obviously going to be easy. The adjusted one gets a little freaky. I have to whip out the I think the PowerPoint or the Excel. I'll whip out the Excel sheet to show you guys what I'm talking about. So here, the first column is the open column. What does the open column mean? The open column literally means the first trading price of that day. So as of the January 2nd, when the day started. So first of all, the stock market, being a public market, is traded, if there's no holidays, from Monday to Friday, starting at 9:30 p.m. At 9:30 p.m. is the opening bell. That's when the trading starts. And the trading stops at, if you were to say 5 p.m., what is wrong with you? Are you insane? It is 4 p.m. Who the hell wants to work till 5 p.m.? Damn it. We are in Wall Street. We do not want to work till 5 p.m. 9:30 a.m. to 4 p.m. 4 p.m. is when the market ends. Now, they do have after-hours trading, which you guys do not need to concern yourselves with, because that is when the sharks trade, all right? Occasionally, I'll dabble and do a little after-hours trading in the prime market, but for you guys, I strongly recommend you keep your trading till 9:30 a.m. to 4 p.m. because that's when you have a lot of liquidity and good price offerings, right? Good price offerings. You won't be taken advantage of by people like moi. All right. So that's the opening price. So at 9:30 a.m., that is the first price. That is the first price it's traded at. Done. So what is this? What is high? High is that at any moment from 9:30 a.m. to 4 p.m., the highest price that stock was traded for. Okay, the highest price it was traded for. So then what is low? Right? Low is obviously the lowest price from that time frame of 9:30 a.m. to 4 p.m. that it was traded at. Now we don't know chronologically when that happened, right? We don't know when it happened. All we know is this was the opening price. At some point it reached the high of that. At some point it reached the low of that. We don't know which came first, the low or the high. You have to literally look at maybe charts and graphs to do that, right? But from this table we won't know that. By the way, these points are usually used for what we call technical trading or charting, which is, lends itself to time series, the class time series, and which I think like 99% of college students, if they do trading, they do technical analysis. Yo, this price went up here. It was like half the price last week, so it's gonna like go down. That kind of talk, right? Technical trading is probably the easiest stuff to do, and the overwhelmingly majority of people are not good at it, right? There are a few people that are really good at it, and they're very famous on the street for it. But majority of people that do this are not good at it, including yours truly. I'm not really a technical analyst or a charter or anything like that. Although I will probably blog some things about it because my alumni, they just can't help themselves. So might as well at least understand the technicalities around it before you dabble in it. So anyway, that's the low price, and this is the close price. Okay, this is the close price. Now, what is the close price? Close price is at the last transaction at or before 4 p.m. At or immediately before 4 p.m. All right, basically the price of the stock, of the last transaction of the stock for the day at 4 p.m. Done. That's the closing price. Done before the bell rings or when the bell is ringing. Okay. What is volume? This is awesome. Volume is literally the amount of shares that were traded for that day. So on the 1st of 2020, you see about 9.5 mil. The next day, you see about 17 million shares being traded. This is no joke, people. Look at the prices these are being traded at, right? This is how much money is being traded every day in these public markets. This is just one stock. And then finally, we get to the last column, which is the adjusted column. This is the column that we tend to use the most. All right, so now this leads us to the adjusted column. What is the adjusted column? The adjusted column, if you notice, the values are the same, right? It's the same thing as close. Why is that the case? But in this case, but in other situations, they'll be different. For example, if I were to click on Tesla right here. Oh, this is the same too. Maybe it's not an example. Let me go ahead and run this for Apple. Let me do get symbols on Apple. I have Apple there now. Excellent. So here now you see there's a slight, so in Tesla you saw that adjusted close, the adjusted column right here, and the closed column were the same thing. But here you'll notice they're slightly different. Why? What is happening? What happens is that the close price sometimes has to be adjusted because based on certain corporate actions. I'll state it again. The close price has to be adjusted because of certain corporate actions. What do I mean by corporate actions? Paying dividends. Paying dividends will affect the hypothetical closing price, right? The hypothetical closing price, because the closing price might be adjusted because of the dividend, right? Because it'll be slightly different than what the ideal closing price is without the dividend, and that's what the adjusted value does. Another example is splits, stock splits, right? Stock splits. And here I'll give you an actual example. If I were to open up Excel, right, let me give you a simple example. What's going on here? All right, so here I have my trusty Excel sheet. So what's happening here, guys, is that let's say hypothetically you have a public company. You have, let's say, 100 shares, right? And these 100 shares are traded at $5 a piece in the market. So this means your company, guys, is worth $500. That's the market value of your company, $500, okay? Now, let's say, and again, these 100 shares, when I say you have 100 shares that are available for public trade, that means that you have 100 shares out there that the brokers like Ameritrade or Robinhood, whatever, can buy and sell. Right? There's 100 shares out there for the public to trade. For the public to trade. Let's say now, the next day, overnight, your company decides to buy back 50 of the shares. So that there's now, instead of 100 shares out there for the public to buy and sell, there's only 50 shares. So let's say 50 shares went out of circulation, and now there's only 50 shares left. Okay? The day before, your company was worth $500 when there was 100 shares out at $5 a share. Now there's only 50 shares. Well, what happened? Right? Did anything fundamentally change about your company so that the market value should go down to $250? No. So then what's going to happen if there's half the amount of shares there and the assumption still is that your company should be worth only $500? The price will change. In fact, what's going to happen now is overnight, the price of the stocks will become $10 a piece. $10 a piece. And that's basically what happens when companies do buybacks. Right? That's what happens when companies do buybacks. So what happens is overnight you'll see, like, historically you'll see the price around $5, and then all of a sudden out of nowhere this price will become $10 going forward. All right. Now, did the stock appreciate? Did it go up 100%? No, it didn't. The shares just went down. That's all. The amount of shares that were there just went down. So what would happen is on the closing column, right? The close column would basically have like shares around 5, 4, prices, 6, 5, something hovering around 5, right? And then all of a sudden, let's say at this point, stock split happened. And then out of nowhere, the next day, it's going to open at 10, 11, 9, 8, back to 10, blah, blah, blah. If you were to do any kind of historical analysis on the prices or use it for some sort of model, this looks like as though, oh my God, at this point in time, the stock price just doubled. It didn't. It didn't. The shares just went down by half. This is why there would be an adjusted close column, right? Adjusted close column, the adjusted column. And what this does is now, this simply recalculates the price as though it was always 50 shares instead of 100. So what will happen is if I take from this point on was when the split happened. So let me highlight this. Format cells. And I will give a color, a background color. Where's my background color, man? Where's my back color, man? Border fill. There we go, fill. So I'll make this a light yellow. Done. So this is the point where after the split happened. The stock buyback happened. Okay? And so what will happen here is this will be the same in the adjusted close column. Done. But what will happen going backwards, the adjusted close column, what happens is it goes back in time, recalculating what the closing price would have been based on the amount of shares. So if this was the $5 when there was 100 shares, so it would recalculate with the price based on if it was 50 shares. So 50 shares, this would go to 10. At $3 for 100 shares, this would go to 6. this would go to 10, this would go to 12, this would go to 8, and this will go to 10. You see? That's why the adjusted close column is always, not always, but at certain points in time, it's different than the close column. But more recently, it's always, the more recent data, it's always the same as a close column. And that's an example of why we have the adjusted close column. The adjusted close column is so that we can have a more consistent difference in the day-to-day prices going over time within the context of corporate actions. And obviously, the exact opposite is the case if you were to issue more shares. If a company issues more shares, then each subsequent price of the stock goes down. For example, there was a point in time where Apple had to, I think they did a 5-for-1 split. Their stock was trading around $500. And Carl Icahn, he's a big activist hedge fund manager, he came in and said to Tim Cook, and he said, hey, listen, bud, right? What he did was he bought a majority amount of the stocks. This is what activist hedge funds do. Activist hedge funds, they're massive hedge funds, and they'll put a lot of money in a particular stock, so they become one of the majority shareholders. In that case, I think Carl Icahn ended up buying around like 7 or 8% or 9% of the company, which I know it doesn't seem, you're like, that doesn't seem like majority. But when you have a massive company like Apple, somebody that owns like 8-9% of shares, they control a large voting block, right? They control a large voting block. That's massive, having 8 or 9% of the votes for a company like Apple. And by the way, that is true. Each share you own is a vote, right? Don't forget, these are public companies. So when there's quarterly meetings and things are up for a vote, right? People's stock compensation plans, all that other stuff, you get a vote, right? You get a vote. So usually people vote by proxy. They allocate their prime broker or some other entity to do the voting for them. They don't take much concern in it. So what Oracle Icahn does is like, all right, look, he takes a huge share, calls up Tim Cook and like, hey, buddy, I think the stock was trading at $1,000 and they did a 10-to-1 split, whatever. Or I'm sorry, a 1-to-10 split. And it's something like that, 1-to-5 or 1-to-10, I can't recall. And so Oracle Icahn was like, listen, Tim, hey, Timmy boy, listen, you should do a stock split, right? Why would Tim Cook listen to Carl Icahn? Because Carl Icahn can make his life difficult. That's basically the bottom line, right? Carl Icahn, I mean, he might have some good points as to why they should do a stock split or not. In the end, who really cares? The bottom line is Carl Icahn has votes. He can cause problems for the board, cause problems for Tim Cook, because he just has so many voters, right? Because he has so many votes. So the bottom line is they relent. They're like, all right, you want to do a stock split, we'll do a stock split. So I think they did a 10-for-1 split. And look, I mean, it helped Apple. It appreciates the price. So what happens is, let's say hypothetically Apple was trading at $1,000. A 1-for-10 split means, okay, we're splitting each share into 10 shares. Okay, so when you do that, when you're splitting each share into 10 shares, what happens to the price overnight? It goes from $1,000 to $100 a share, right? $100 a share. Now, why the hell would Carl Icahn care about this? What does this have to do with his life? The reason being because there's a psychological effect there. When you do a stock split, right, what happened all of a sudden? It went from 1,000 to 100. What does that allow other investors to do that don't have that much money to buy $1,000 stock and want to buy Apple? $100? Cool. I'll buy it. I can now buy Apple? Sounds good. You get a little more people that you open yourself up to new pools of investors that don't have that much capital and might want to buy your company. These guys start buying your company. So this is a demographic that wasn't buying your shares in your company, and now they're buying shares in your company. So what happens to the demand of the stock? It tends to go up a little, right? What's going to happen to the price? It might go up to 100, 101, 102, 103, 104, whatever. So what happened overnight? You subsequently appreciated the price of the stock by splitting it. All right. So Carl Icahn, he'll be like, all right, let's split it. It splits. If it goes up enough, like let's say it goes from 100 to 110 or 115, whatever, Carl Icahn will be like, oh, let's say to 120. Cool. From 100 to 120, that's a 20% profit. Carl Icahn, in maybe a matter of a few days or a few weeks, Carl Icahn will be all right, cool. Thanks, fellas. I'm out. And then he'll start selling out his shares. And then he'll move on to the next company. All right? These are what we call active investors. Yes, this is capitalism. Yes, this is not illegal. This is perfectly allowed. You're perfectly allowed to do this stuff. And if you're thinking, wow, this is kind of weird and strange, you don't know what just happened, right? Recently, with the whole stimulus, with the whole COVID, the COVID pandemic, and how the market stopped, and then with Congress, both Republicans and Democrats, right? Listen, give Republicans credit. They never deny who they are. The Democrats, oh my God, the Democrats, as far as I'm concerned, if you're a Democrat, you should you should uh, you should vote out every Democratic Congressperson, minus AOC. I'll give AOC some leeway because the second stimulus she was petitioning a little bit, but majority, all those people, they should be you. Any Democrat, I'm not a Democrat. Any Democrat should not vote for them. They should vote for any Democrat out. Anybody else but those guys. You guys don't know what happened. The Democrats totally threw. Again, Republicans, they don't care about the working class. I don't care what Trump says. We all know this. He don't care, right? They do their thing. Corporate America, that's their thing, right? We're corporate America. We just say, thank you, Republicans. Thank you, right? But the Democrats, oh my, they talk a big game. They just threw everybody under the bus, right? And we could talk about that during Q&A session. But anyway, this is perfectly legal. And Carl Icahn does his thing, and so this is what we call these are what we call activist investors, activist hedge funds. Activist hedge funds, they take a large share of a company, and they actively, I would say, nag the board to make some sort of changes in like the share structure that that would obviously benefit the share price in the short term, so that they can take a nice profit. Now, some people might argue, listen, what's wrong with this? This is great. What's fantastic? What's wrong with this? Look, there's nothing wrong with it as long as the action that the board takes is going to be good for the company in the long term, right? And it aligns with the values and the strategies of the company. There's nothing wrong with it. But if it's something just a short-term gain, a lot of times short-term gains, they don't have any positive effects long-term, right? And again, I can give you a whole example about this. So that's basically the example here. So that's basically what the adjusted price is. So that's why we have the adjusted column. So for Apple, notice they're slightly different. But if we were to go all the way down, let me do tail Apple, tail Apple. And this time I will do, oh, sorry, got to put the table name, comma 10. Did I spell it wrong? No, I got Apple. What's going on here? AAPL. Oh, cool. I got an error of some sort. Oh, I have Apple lowercase, dummy. Do it here. There we go. 10. I had a lowercase l. All right, so here, oh, let me scooch this out, rerun that so you guys can see it clearly. All right, so here now, look at the adjusted and closed columns, guys. They're exactly the same. They're exactly the same. Because anytime any kind of corporate action happens, right, the adjusted closed column will be like, all right, cool. I'm going to go, this is now the same, but I'm going to go back in time now and make sure I adjust the prices for everything else. All right, so that's the difference between the adjusted closed column and the closed column. And this is why we tend to use the adjusted column like 90-something% of the time, guys. This is why we use that column when we want prices. All right, so that is the 6 columns. The 6 columns. Now here, quantmod, these XTS tables, they have certain functionalities built into them that you can use to make your life easier. These functionalities just belong to the quantmod XTS table and cannot be confused with being used for other kinds of tables because, like I said, it's just for the quantmod XTS table. All right, what do these functions do? OP gets you the open column. This literally will give you a certain column. HI will give you the high column. LO will give you the low column. CL will give you the closed column. VO will give you the volume. AD gives you adjusted close. All right, fair enough. But then they have combinations. HLC will give you the high, low, closed columns. OHLC will give you open, high, low column, and et cetera, et cetera. All right, so let me show you a little something of what's going on there. If I were, and this is kind of hard to see because your console never gives you too much data. It always cuts off the data. Some of you guys are wondering like, hey, it doesn't show me everything. That's right, it cuts off the data. And the reason it cuts off the data, because at the end of the day, RStudio R is about data analysis, data science. And one of the philosophies between data analysis and data science is that the human mind can only process a certain amount of data. So from R's point of view is if we ask for like 1,000 rows of data, it might cut off some of the data for aesthetics reasons again, because when it's outputting, if you're trying to output like 1,000 rows, it's going to take up processing power, speed. So it might just give you like the first 50 and the last 50, something along those lines. And again, the reason it does it is because it's like, look, I'm not going to give you all 1,000 rows because your human mind's not going to be able to process it. What kind of game you guys are playing? So it kind of forces us to summarize and take a summary of the data. But if we ever actually wanted to see the data, you can always click it right here. You can always take a subset of the table, click it over here, and view it in the grid format like we have up here. Let me close some of these eyes out. All right, so you guys have that functionality. Now, let's use the columns. Let me show you what I'm talking about. So I'll use Batman. So for Batman, all right, let's say I want my slide here. Let's say, yeah, let's take the column that I like, the column that we use 9% of the time, the adjusted close column. So if I just wanted the adjusted close column, if I run Batman right here, you'll notice it gives me all 6 columns, right? All 6 columns. Obviously the last one, they carried it, whatever, it doesn't matter. If I just want the last column, if I just want just a close column, if I just type in A, D, capital A, lowercase d, remember that's a function, and within the function I pass in the table, which is Batman. Now, what happens is, let me scroll all the way up. Right, you'll notice it went from, remember my Batman is just the beginning of just 2020 data. This is why it's not cutting it off. I literally have, this is one of the reasons I took the summary of the data. So now it starts from May, goes all the way up to January, and it's just one column. See, that's the command right there that got passed down. It's just one column. AD simply gives me the column that I want. Let's do HI. And it's really easy to remember these functions, guys, because there's literally the word. It's the 2 letters of the word where the first letter is capital, the second letter is lowercase. So if I want the high one, the high column, scroll all the way up, the high column. If I want the low one, etc., etc., etc. Cool? Cool. All right, now, that's one way to get the column data, but I can also get the data using the grid way. The grid way. Well, what's the grid way, people? Your table, click on Batman right there, it's like an Excel sheet, isn't it? It looks like an Excel sheet. An Excel sheet has what? An Excel sheet, each cell is defined by what? It is defined by the row number and the column letter. So A1 would basically be the first cell because it's in the column A and row 1. All right? Sort of the same concept in Batman. With tables in R. Except we now give, just like we do with a vector, we give the position of the value in the vector, the bookshelf. Well, with the grid method, now I want you to think of a library of bookshelves, all stacked side by side with each other. All stacked side by side with each other. We can now specify not just the row, but the column. And that's why there will be, when you have a comma between your brackets, that's a hint to you, like, oh, you're dealing with a data table, or some sort of 2-dimensional data container, a 2-dimensional data container, which is basically what table is. Table is a 2-dimensional data container. Alrighty, now I want to get the adjusted close column just like I did in line 14. How, pray tell, will I do it? Okay, here I am going to, like I said before, we got to give 2 positions, right? We got to give the row and the columns we want. Now, to the left of the comma goes the rows. To the right of the comma goes the columns. Remember this, I had 2 students that messed this up on the midterm once. They got those questions wrong. To the left of the comma goes the rows, to the right of the comma goes the columns. For my foundation students, this is exactly like pandas, so this should not be a problem for you. This should not be a problem for you. It's the same. All right, so let's go ahead and get the adjusted closed column. If you recall, the adjusted closed column was my 6th column. I shall put a 6 in there. All right, that is the column section. I shall put a 6. So that is basically saying, give me the 6th column. To the left of the comma, I'm putting nothing. Why am I putting nothing? Because when you put nothing in there, that's basically telling R, hey, give me all the rows. If you don't specify a certain row, then that means then you're taking all the rows. So when I execute this line of code right here, you will notice it's the same thing. As I get the same thing back as I did in line 14. Line 17 gives me the same result as line 14 does. I just did it 2 different ways. And if I want the high column, all the rows from the high column, which column was the high column? Which number was it? It was the open high, so it was the 2nd column. And again, you'll notice if I scroll up, I got the high, and if I want the low one was the 3rd column. Right, so I'm showing you 2 different ways to get those columns of prices. That's the low column right there. Sweet. All right, all right, all right. Now look, some other cool functionality I'll show you guys in a moment. But now let's say we chose everything, right? Everything to the left, to the right, whatever the comma, whatever. I mean, to the left of the comma. Basically, that meant we chose all the rows. But let's say I want to choose a specific row. Then you simply just put the number to the left of the comma. And in this case, ladies and gentlemen, if I were to, let me copy this right here, and I type this in, ta-da, I now chose, this is what's happening. I chose the first row of the 6th column. Because I'm choosing a specific row, and let me say that again. Because I'm choosing one specific row and one specific column, that gives me just one cell of information. The adjusted close price for January 2nd to 2020, the first line item. If I were to do it for the 2nd row, it would give me for January 3rd, 2020. If I did it for the 3rd row, January 6th, and so on, and so on, and so on. All right. Likewise, if I messed with this right here, change it to 1, which is the opening price. Now I have the opening price for January 6th to 2020. January 6th, 2020. Alrighty, that is how the grid method works. Oh, and now we jump into slicing by dates, and we'll get to that in a second. Hold on, we'll get to that in a second, right? But I want to show you guys a little some as well. All right, now we're choosing one cell over here. We're choosing one cell over here. If I take line 14, line 15, line 16 again, there I chose all those columns, right? There I chose all those columns. Well, how would I be able to get a specific row within the adjusted closed column within the high column? Let's say I wanted the high, the first row again. Let's say I wanted the first row again. How would I get the first row for adjusted close, high, low, etc., etc.? Well, I can basically just do that explicitly. I can now basically use the combined. I can combine the grid and these functionalities at the same time. So basically, I would say, all right, give me right. So what's happening? Go inside out. This line right here, this part of the code right here, gives you all the rows, all the columns for the first row. Why does it give you all the columns? Because look, I'm specifying here the first row, but to the right of the comma is nothing there. Because nothing's there, it's taking all, because I'm not specifying a certain column, I'm taking all the columns. I'm taking all the columns right there, right? I'm taking all the columns. And when I pass this, so this becomes basically a subset of the table, all right? The first row, all the columns. And when I put this subset of this table, which basically is one row of data with just 6 columns, into the AD function, I get basically just the adjusted close column of that one row, right? Because when I'm slicing this Batman table, it's still the XTS quantmod table. Yes, I can choose one particular row and cell right here, one row and column, one cell. But even though this is one number coming back at me, it's still an XTS table coming back at me. It's still an XTS table coming back at me. All right? So that is something we have to understand, that it's still, even though it's just one value, it's still, the type of data container is still an XTS table. Okay? Still an XTS table. All right, now, get to some more fun stuff. We get to now the whole point of using an XTS table. The reason why quantmod uses an XTS table. Slicing by date. Slicing by date. And we throw in some additional functionality in there. First and last. First and last is like tail and head in R. You saw me use tail already. So last is similar to it. First is like a head functionality you guys saw me do. But first and last are functionality that's built into the quantmod package, right? It's redundant, obviously, for what head and tail do, but nevertheless, I still show you. You can use it. You can use tail, head, whatever. So let's start with Batman 2014. Well, I can't do Batman 2014. I only have Batman 2020. So let me grab Tesla. All right, let me grab Tesla. Now, if I were to do Tesla bracket quote 2018. All right. Now what's going on? Okay, I don't have a comma. Because of the fact that I don't have a comma, what's going to happen here is, let's say I did Tesla 1. Right? What do you think is going to happen here if I don't have specified comma? What happens is, if you don't specify a comma and you put some sort of number there or some sort of value, it just assumes you're specifying a certain row and all the columns. By default, it's thinking, okay, you're calling all the columns, but you're specifying a certain row. So here, it's going to give me the first row and all the columns, right? Because there's no comma. So this is basically the same thing as this, all right? All right? Now, go back to this. If that is the case, then what's going on here? I'm specifying a certain amount of rows I want and all the columns. Now notice I'm putting in a date within quotes. I'm just putting in the year. I'm just putting in the year, 2018. What do you guys think is going to happen? It's going to grab all the rows that are from, because remember, the XTS table, each row is uniquely labeled to a certain date. This is the power of XTS tables. So now what's going to happen is it's going to grab every row from 2018, right? And you can't see it because, like here, you see this right here, 1,085 rows. It's going to take a subset of data. It's not going to show you all the data. But if I were to save it into another table, you would see it. In fact, let me do that. Let me do that so I can show you. So here, I'm going to do TT equals Tesla. All right, TT equals Tesla 2018. So I'm creating a subset table that's just 2018. And here now you can see all the columns starting from the January 2nd, 2018. It'll scroll all the way down to 12/31st, 2018. What the hell? Why do we have a training day for 31st? Oh, okay, New Year's Eve. Yeah, that's fine. I'll take that. All right, you see that? So we filtered for all the days of 2018. Pretty cool, huh? And you have to do it in quotes. You have to always give any kind of date objects in quotes. Fantastic. Let's say we wanted from 2018 to 2019. All right, we wanted 2 years. How do we do that? You can use a syntax from line 2 over here or line 3, a slash or a colon. But understand that slash is happening within the quotes, and that colon is happening within the quotes. Let me do this again, right? So if I do this, slash 2019, right? Now it's saying, okay, give it to me from 2018 to 2019. I run this, a TT, okay, the first row, 2018, that's fine. Go all the way down. And you'll see now the last row is 2019, 12/31st. 2019, 12/31st. Pretty cool, huh? Alrighty, so that's what the slash does. And you can do as many years as you want. 2018, I mean, you can go from, let's say hypothetically, if we had from like 1998, you can go 1998 slash 2019, and it'll give you all the dates, all the rows from those years, from 1998 to 2019 continuously. Right, so that's the cool thing about these XTS slicing stuff. Now we combine it using that first and last function I was talking about. All right, that first and last function I was talking about. All right, so here, now, if I were to do first, and within the first function, I'm going to pass this command, this table. Now I'm passing the Tesla table in, but notice I'm passing the Tesla table in filtered for 2018 to 2019 dates. So the first value that is seen by the first function will be 2018-01-02. It has no idea that Tesla has prices for 2010 because all it's getting is this subset of the data, right? Let's say I want to see the first 3 rows instead of, notice the default for first is just 1 row. If I do comma after that data object, after that data container, if I do comma and then put in, let's say, 5, now I'm getting the first 5 rows from that point in time. Again, it's working just like the head function, Same thing with last. Last, let me get rid of that number again. The default is 1, so I have 1 row. Let me scroll over here so it's just cleaner. Oops, what the, oh, stop. Oh no, okay, good. So if I do last, I accidentally ran all the lines of code. So here now, last, it gives you the last row, 2019, 12/30. Sweet. Let's say I wanted the last 4. Boom. See that? And this is how you can use these filters with the date filtering. I'm sorry, you can use these functions with the date filtering to basically say, oh, give me the first trading days of January, first 5 trading days of January, first 5 trading days of January 3rd of January of 2020, first trading days of March, right? This is how you use this functionality, grab these prices really, really fast, right? What am I teaching you? I'm teaching you to slice and dice the data, slice and dice the data. Alrighty. So that is slicing and dicing by the dates. But like I said before, let's say we want specific. We want it more specific. We don't want just a certain year. We want a certain month. How do we do that? Well, here I now write out more of the date. So before I did it only for the year, 2018, or in my case, probably 2020. But I can also specify the month. So if I do 2020, and here I say again December. Yeah, let me do December. I'll just grab another one. So I'll do, let's say, I have the Tesla. Yeah, I'll use the Tesla one instead of Batman. So I'll do Tesla, bracket, quote, 2000, let's do 2019, dash 12. Boom. All right. Now I'm scrolling. Oh, let me do this again just so it's cleaner. No. All right, perfect. Now. All right, so now you'll notice it starts with the 2nd of December. The 1st was probably a weekend or something. And it'll give you all the data from the 1st of December to the end of December for 2019. Just because now we're saying, hey, I don't want just all the rows from 2019. I want all the rows from December of 2019. And that's exactly what it did. That's exactly what it gave me. And we can get even more nitty and gritty. Let's say I wanted all the rows from December 2018 to, in my case, 2019, but up till Christmas. Not now, I don't want the whole month. I want it up till Christmas. And we can say Christmas now, people, because Trump is president. You're welcome. All right? It's a little joke. So anyway, a little MAGA joke there. So from 2019-12 to Christmas. All right? So how do I do that? Copy this. And I do slash. I do the slash. And now I say 2019-12. And I get even more specific with the date. I say, hey, give it to me for the month of December up to the month of December of the 25th of the month of December. That's basically, if you want to think about it backwards like that. I run this, and now it gives it to me from December 2nd, because that's the first trading day of December 2nd, up to Christmas Eve, the 24th. It does not give it to me for the 25th because there is no transaction for the 25th, right? But that's okay. For this range, it'll give you all the transactions that exist within this range. And that is why we have it from the 2nd all the way to the 24th, right? All the way to the 24th, because those are the only transactions within that time frame. And that's how you can get even more and more concise with the data and the prices you want, Very convenient. And we can also mix match our add, our last, and all that other stuff. All right, so here I will throw in my last. Throw in the last. Actually, let me copy this. Throw in the last function. I'll take the last 3 days. And now I have the last trading 3 trading days within the time frame of December of 2019, from the beginning of the month till Christmas. But the last 3 transactions, boom, done. I can use obviously my head one. We can get even more creative, right? We can take this line and we could filter this even more. We can say, look, I want those last 3 transactions for that time frame, but I just want the adjusted close column. So now I take all of this and I pass it into the AD function, and that will give me now what? It'll give me the same thing as before, the same 3 rows as before. Let me scroll up so you can see this. Same 3 rows as before, except now it's filtering even more. It's just giving me the adjusted close column, and that's why we have this. Same 3 rows, except now I filtered for that column. And if I wanted to, I could do the same thing again, but I could use the grid methodology. So I'll do the same thing as line 38, except now I will use the grid functionality. To do the grid functionality, remember, you have to give 2 coordinates to the data container Tesla. I only have 1 I'm sorry, I have to specify not just rows, but columns as well to use the grid methodology. Here, I'm only specifying the rows. So if I want to specify the columns, I must do it within the square brackets. Here's the square brackets, and within the square brackets, the open and close, you can see of the data container. We specified filters for the rows, and now I'm going to specify a filter for the columns by adding a comma in between those square brackets, where to the left of the comma goes the row filters, and now to the right of the comma will go the column filters. In this case, I'm filtering for the 6th column, which is going to be my adjusted column. So line 38 and line 39 give me the same values. Albeit we got it 2 different ways, we got the same values. All right. And now I'm introducing you to a function called as.vector. Now, R has a whole series of functions in it that start with the word as dot. If I could go to RStudio right here, show you. As dot, excellent. And they all pop through. You see this whole So many as dot this, as dot that, as dot that, right? There's so many of them. What do these as dot functions do? These as dot functions transform one data container or one data type into another data container or another data type. That's basically what's happening. That's basically what this as dot function does. It changes from one data container into another data container or one data type into another data type. All right? So what does as dot vector do? Well, if you recall, I'm going to take I'll take this line 38 again. And this time I will take the last value of Christmas, the last trading day. This is now going to give me the last trading day, last adjusted close price of Tesla right before Christmas. So the last transaction was the 24th, $425. Excellent. Excellent. Now, that's just one value. All right? But that one value is coming back one value. But that one value, what type of data container is it? It's still an XTS data table. It's just one row, one column, but it's still an XTS row data table. Let's say I want to use that number in some other more mathematics. I want to use it for more calculations. What happens is if I start using that structure, that one row, one column structure, all my calculations will remain in a one row, one column data container structure. I just want that number, right? And if you recall from our previous video, our previous classes, our previous lecture, the most basic building block data container in R is a vector. So we want it as basically a simple vector. Enter the as.vector function. That is what the as.vector function does. The as.vector function basically takes data from a more advanced data container and it simply converts it into a simple vector. So if I were to take now this same line, 41, copy it, paste it in within the parentheses, right? And now run it, you will see now I just get the number. I now just get the number. I don't get this row, this little index here, nor do I get the column name, because now it's not an XTS table. Now, what I did was I took that XTS table and with that value that I wanted, and I converted it into a simple vector. And that's why I got that simple value, 425.25. We do this just so our calculations, when we're trying to view the results of our calculations or ratios, it just doesn't get insane. It stays as simple numbers for us to use. All right, so that's the logic behind it. That's the logic behind it, and that's why the as.vector function is necessary for us to use. All right, now we are ready to do our lab. And today's lab, ladies and gentlemen, first of all, I have the solution right there in front of you. Let me scroll over here to explain to you what is happening in the lab. The lab, as I explained to you guys, as we explained to you guys when we did our first lab, for our first lab, we calculated the compound return of your education. You took your 4 years or your expected 4 years tuition, and you also took your expected first year's compensation, or maybe first 2-3 years compensation based on how much you paid, right? And you figure out your compound return for your education. Fantastic, great. Now, the question is, was that a good number or a bad number? How are you gonna know? You gotta compare it. You gotta compare it to what actually happened in the market in those 4 periods. In those 4 periods, hypothetically, those four periods that you would have went to college. Now, we're gonna have to stretch the truth a little bit because you guys are seniors and juniors. We can't perfectly recreate how much your college tuition investment would have done in the market, in the stock market, because we don't know what the heck the prices will be in the future. All right, so this is not an apples to apples analysis. What we're gonna do is we're gonna cheat. We're going to assume that you guys all graduated already, right? That's what we're gonna do. We're gonna assume you guys all graduated, or yes, we're gonna assume that you guys all graduated this past May of 2000. For anybody watching this video in the future, so we're basically gonna assume that everyone graduated this past May, and you guys are slightly older than you guys are right now. Again, I apologize for this. But for my hypothetical student, this is how we're going to basically figure it out. But obviously, you guys can go back and you can figure out how much money you would have made so far in your actual education. I'll let you guys do that. But to do apples to apples, we can't really do. So we're going to have to suspend. We're going to have to make some assumptions and suspend reality a little bit to basically figure out, hey, if we put our money into the market, you know what? Heck with it. We'll do it. Heck with that. I'm gonna call an audible. All right. So I will do two scenarios. I will do a scenario for my fictional student that already graduated and calculate their compound return, and then I'm going to do another scenario for, I would say, a senior. I would say a rising senior, and the rising juniors, you guys can adjust it accordingly. Of what is your compound return so far? What is your compound return so far of the money you invested? Right. So we will do both. We will do both. Right. So by what I'm saying, by investing your money so far, I'm saying, look, take that. Remember the example I gave was 11,000 each year the student invested. So in this time, instead of taking that 11,000 and giving it to college, that student took that 11,000 and he literally put it into the stock market. Or I'm sorry, he or she put it into the stock market. He or she literally put it into the stock market. Okay, and the way they put it into the stock market is they bought a particular type of security called an ETF, what we call an exchange traded fund. And the particular ETF they bought was an SPY. All right, the SPY, which represents the S&P 500. Okay, now, ladies and gentlemen, what I'm going to do is I'm going to end this video because now we're approaching the hour 20 mark, and we'll continue this in part B of Lab 2. All right, so I'll see you guys on the second video. All right, bye-bye.